There's something undeniably mesmerizing about the night sky, the way it stretches endlessly, speckled with stars, each one a silent witness to the universe's greatest secrets. But what if I told you there's a galaxy out there, hidden in the cosmic tapestry, that defies everything we think we know about space? Meet NGC 262, a celestial enigma that's baffled astronomers for decades. This isn't just another swirl of stars and dust. It's a treasure trove of mysteries, each more perplexing than the last. From unexplained energy surges to structures that shouldn't exist according to our current laws of physics, NGC 262 is a puzzle waiting to be solved. And today, we're diving deep into 30 of its strangest phenomena that challenge our understanding of the cosmos itself. Picture this, a galaxy so peculiar that it seems to operate by its own rules. While most galaxies rotate in predictable patterns, NGC 262 dances to a different tune. Its core emits bursts of energy with no clear source, like a cosmic lighthouse flashing signals we can't decipher. Some scientists speculate these could be signs of advanced alien technology, while others believe we're witnessing entirely new astronomical processes. Then there are the mysterious dark regions, patches of space where light simply vanishes, as if swallowed by something we can't even detect. What's hiding in those shadows? The possibilities are as thrilling as they are terrifying. This isn't just a journey through space, it's a journey into the unknown. Every strange phenomenon in NGC 262 is a clue, a piece of a grander puzzle that could redefine our place in the universe. Whether you're a seasoned space enthusiast or just someone who gazes up at the stars in wonder, this exploration is for you. By the end of this video, you'll see the cosmos in a whole new light, one where the rules aren't just broken, they're rewritten. So buckle up, we're about to venture into one of the most mysterious corners of the universe, where every discovery raises more questions than answers. Ready to uncover the secrets of NGC 262? Let's begin. Among all the bizarre features of NGC 262, few are as hauntingly mysterious as its phantom spiral arms. Unlike the steady, well-defined arms of galaxies like our Milky Way, these ghostly structures flicker in and out of existence like cosmic apparitions. One moment, telescopic observations reveal elegant, swirling extensions of stars and gas. The next, they've vanished without a trace, leaving astronomers scratching their heads. What makes these arms so baffling is their defiance of galactic norms. Spiral arms typically form through density waves, where gravitational forces compress gas and dust into stable, long-lasting structures. But NGC 262's arms don't obey these rules. They appear sporadically, sometimes stretching tens of thousands of light-years before dissolving into the void. Some researchers suggest these fleeting arms could be the result of dark matter clumps passing through the galaxy, their immense gravity briefly warping visible matter into these eerie shapes before moving on. Others propose that we're witnessing the aftermath of a galactic collision, one so violent it sent ripples through the galaxy's structure, creating temporary distortions that fade over time. Then there's the strangest part. These phantom arms emit faint, unnatural light patterns. Spectroscopy reveals wavelengths that don't match typical stellar radiation, hinting at unknown energy sources at work. Could it be some exotic form of matter interacting with the galaxy's fabric, or an advanced phenomenon we've yet to discover? The answers are still hidden in the depths of NGC 262, waiting for the next breakthrough observation to pull them into the light. For now, this phenomenon remains one of the galaxy's most captivating puzzles, a reminder that even our most advanced cosmic models can't always predict what we'll find in the vast unknown. Deep within the heart of NGC 262 lies a supermassive black hole, but this isn't your typical cosmic vacuum. Something extraordinary happens here, something that's left scientists utterly bewildered. Light doesn't just vanish into its abyss, it bounces back, repeating in eerie, rhythmic pulses like a cosmic echo. Imagine shouting into a cavern and hearing your voice return not once, but multiple times, each repetition slightly distorted yet unmistakably yours. That's the kind of phenomenon astronomers have observed near this black hole, except instead of sound, it's light itself that seems trapped in a loop. These echoes aren't random. They follow precise intervals, sometimes separated by hours, sometimes by days, as if space-time itself is folding in ways we can't yet explain. One leading theory suggests the black hole's immense gravity is warping the fabric of the universe around it, creating a natural hall of mirrors effect. Light trying to escape gets caught in these gravitational twists, forced to circle the black hole multiple times before finally breaking free or succumbing to the darkness. But here's where it gets even stranger. The echoes don't always match the light patterns we'd expect from a typical black hole's accretion disk. Some pulses appear amplified, as if an unseen force is energizing them mid-journey. Could this be evidence of exotic matter particles that defy our current understanding of physics orbiting the black hole? Or might we be witnessing the fallout of a hidden dimension's influence, where gravity behaves in ways our equations can't predict? A handful of daring researchers have even floated the idea that these echoes could be artificial in nature, though most dismiss this as pure speculation. After all, nature has proven time and again that reality often outstrips our wildest imaginations. What makes these echoes so tantalizing is their potential to rewrite the rules. If we can decode their patterns, we might unlock secrets about how black holes evolve, how space-time bends under extreme conditions, or even how information escapes what should be an inescapable grip. For now, NGC 262's black hole keeps its secrets close. It echoes a cryptic message from the edge of the known universe, one we're only beginning to decipher. One of the most unsettling mysteries in NGC 262 involves an entire star cluster, thousands of stars bound together by gravity, that simply blinked out of existence. Astronomers first catalogued this glittering assembly in the early 2000s, tracking its position near the galaxy's outer rim. Then, over a mere decade, it faded from view, not in the slow dimming of aging stars, but as if someone had flipped a cosmic light switch. Telescopes trained on its last known coordinates now reveal nothing but empty space, a void where celestial giants once burned bright. Theories about what happened span the spectrum from unsettling to downright chilling. One possibility is that the cluster's densest stars collapsed in rapid succession, forming a chain reaction of black holes that consumed their neighbors. Imagine a row of dominoes falling, except each domino is a sun meeting a violent end, its remains collapsing into an insatiable gravitational pit. If conditions were just right, or just wrong, this could have unfolded with terrifying speed, leaving no visible debris behind. But there's another, even more provocative idea. What if something or someone harnessed the cluster's energy? The absence of any explosive residue or detectable radiation has led a small contingent of researchers to speculate about advanced extraterrestrial engineering. On Earth, we theorize about Dyson spheres, megastructures that could encircle a star to harvest its power. Could an intelligence far beyond ours have scaled this concept to an entire cluster, dismantling stars not for destruction but for fuel? It's a notion that straddles the line between science and science fiction, yet the total lack of conventional explanations keeps it unsettlingly plausible. What makes this phenomenon especially eerie is the timing. The cluster vanished within a human lifetime, a cosmic eye blink by astronomical standards. Most galactic events unfold over millennia, but this was swift, deliberate, and silent. Whether natural or otherwise, it forces us to confront how little we truly understand about the forces shaping the universe. NGC 262's disappearing act is more than a puzzle. It's a humbling reminder that the cosmos still holds secrets beyond our wildest reckoning, and some of them might be watching us back. In the vast expanse of NGC 262, there's a patch of space so eerily quiet it's been dubbed the radio silence zone. Picture tuning an old radio, searching for static or distant broadcasts, only to hit a frequency where all sound cuts out, not just static but complete, unsettling silence. That's what astronomers encounter when they point their instruments toward this region. Every known radio signal, from the faint whispers of distant pulsars to the background hum of the universe itself, vanishes the moment it crosses an invisible boundary, as if swallowed by an unseen cosmic mute button. This phenomenon bears an uncanny resemblance to Earth's infamous Bermuda Triangle, where ships and planes have vanished without explanation. But while our planet's mystery is often chalked up to natural, if poorly understood phenomena like methane bubbles or magnetic anomalies, the radio silence zone defies even those speculative explanations. The silence isn't intermittent, it's absolute and constant, stretching across a region roughly the size of our solar system. Even more perplexing, the boundary is razor-sharp. On one side, radio waves flow freely, on the other, nothing escapes. It's as if someone drew a line in the cosmic sand and declared, no signals past this point. What could cause such a drastic silencing? One leading hypothesis points to an extreme concentration of magnetized plasma, a soup of charged particles so dense it could absorb or deflect incoming radio waves entirely. But plasmas typically scatter signals, not erase them entirely, and they don't create such precise boundaries. Another theory suggests the presence of a primordial black hole, one so ancient it's cloaked in a veil of dark matter. Its gravitational pull might bend radio waves into oblivion, though why this would happen so selectively in one region remains a mystery. Then there's the more speculative angle. Could this be evidence of something intentional? On Earth, we've theorized about stealth technology that absorbs radar signals. Might an advanced civilization, whether long gone or still thriving, have left behind a cosmic-scale version of such a shield? It's a tantalizing thought, though skeptics argue nature rarely needs extraterrestrial help to produce the extraordinary. Whatever the cause, the radio silence zone stands as one of NGC 262's most provocative puzzles, a place where the universe's usual soundtrack drops to a whisper, leaving us straining to hear what it isn't saying. What makes this silence so profound isn't just the absence of noise, it's the unanswered questions it raises. If radio waves can't penetrate this zone, what else might be hidden inside? Are there objects, events, or even structures lurking there, invisible to our current tools? For now, the zone remains a cosmic dead end, a reminder that even in a universe brimming with signals and light, some corners prefer to keep their secrets quiet. Stretched across the depths of NGC 262, a cosmic funhouse mirror warps reality itself. This gravity lens, a region where the galaxy's immense mass bends space-time, doesn't just slightly distort passing light. It twists entire galaxies into shapes that defy logic. Imagine holding a spoon up to a distant street lamp, watching its reflection stretch and fracture into surreal blobs. Now scale that up to galactic proportions, background galaxies smeared into rings, spirals split into disjointed fragments, even duplicates of the same celestial object appearing side by side like some celestial Photoshop glitch. What makes NGC 262's lens so extraordinary isn't just its strength, but its inconsistency. Most gravitational lenses act like predictable magnifying glasses, bending light symmetrically around massive objects like galaxy clusters. Here, the distortions are chaotic, as if invisible hands are crumpling the fabric of space unevenly. Astronomers have catalogued at least 17 background galaxies warped into impossible configurations. One stretched into a perfect cross, another split into a trio of glowing crescents arranged like a celestial peace sign. The most baffling case, a spiral galaxy bent into a perfect Fibonacci spiral, its arms coiled with mathematical precision far beyond what natural lensing should produce. Theories attempting to explain these anomalies read like a cosmic detective's wildest hunches. Some suggest dark matter filaments, invisible threads of the universe's most elusive substance, are crisscrossing the lensing region, adding unpredictable kinks to spacetime's curvature. Others propose rogue black holes drifting unseen between stars might be amplifying distortions in localized patches. But perhaps the most radical idea comes from a team at the European Southern Observatory, who have crunched the numbers and found the lens's behavior might hint at an unseen dimension's gravitational leakage into our own. Then there's the eerie timing. Unlike static lenses elsewhere, NGC 262's distortions shift over months. Some galaxies flickering between multiple warped states, others momentarily snapping back to their true shapes before twisting anew. It's as if the lens itself is alive, recalibrating its grip on reality. Whether this is due to unseen matter in motion or something far stranger remains unknown, but one thing is certain. In this corner of the cosmos, gravity doesn't just bend light, it sculpts it into a gallery of cosmic impossibilities, each one challenging our textbooks and tantalizing our curiosity. What makes these mirages so valuable isn't just their strangeness, they're cosmic laboratories. By studying how light contorts here, scientists can map the invisible mass distribution of the galaxy itself, like using funhouse mirrors to deduce the shape of the room they're in. Every twisted galaxy is a breadcrumb trail leading us deeper into the dark heart of NGC 262, where the rules of physics as we know them seem less like laws and more like suggestions. Out near the fringes of NGC 262, space itself seems to crackle with cosmic fireworks, bursts of energy so sudden and intense they make supernova look like candle flames. These are the quantum flare bursts, unpredictable eruptions of light and radiation that appear without warning, blaze for mere milliseconds, then vanish as if they never existed. Imagine lightning, but lightning that doesn't follow storms striking at random, in places where our models say it shouldn't be possible, with energies that dwarf anything in nature. What sets these flares apart isn't just their power, but their bizarre signature. When astronomers analyze their light, they find patterns eerily similar to quantum-scale phenomena, particles behaving in ways that should only occur in lab experiments at temperatures near absolute zero. One moment, the flares emit radiation typical of colliding neutron stars. The next, their spectra shift to match the theoretical signatures of antimatter annihilation. It's as if the fabric of space has tiny, invisible fault lines where the rules of physics flicker unpredictably, creating microscopic and temporary rips in reality itself. Theories about their origin split the scientific community down the middle. Mainstream astrophysicists argue these could be the death throes of microscopic black holes, remnants from the early universe evaporating in bursts of Hawking radiation. If true, it would mean NGC 262 is littered with these ancient relics, their final moments detonating like cosmic landmines. But there's a catch. Hawking radiation should be faint and continuous, not violent and sporadic. Could these black holes be interacting with some unseen force, triggering premature explosions? Then there's the more controversial camp. A handful of researchers point out that the flare's timing isn't entirely random. Statistical analyses reveal subtle clustering, as if they're following some hidden algorithm. This has led to speculative and electrifying discussions about whether we're witnessing something engineered. On Earth, quantum computers manipulate particles in controlled states to perform calculations. Could an intelligence billions of years ahead of us have scaled this concept to astronomical proportions, using flares to transmit information or even reshape spacetime itself? Skeptics dismiss this as wishful thinking, but even they admit the flares defy conventional explanation. Perhaps the most unsettling detail is what happens just before each burst. Telescopes have detected fleeting distortions in the surrounding space, not gravitational waves, but something akin to a shimmer, like heat haze over a desert. Some instruments even pick up faint, repeating pulses in these moments, patterns that resemble counting sequences. It's enough to make even the most skeptical astronomer pause. Are these merely artifacts of exotic physics, or could they be the fingerprints of something beyond our current understanding? For now, the quantum flare bursts remain NGC 262's most electrifying enigma. Each detection sends researchers scrambling to adjust their theories, every new burst rewriting the boundaries of what we thought possible. Whether natural or otherwise, they force us to confront a humbling truth. The universe may harbor energies and mechanisms we haven't even begun to imagine, flickering at the edges of our perception, waiting to be understood, or perhaps waiting for us to catch up. Buried in the swirling depths of NGC 262, a planet shimmers like a cosmic chandelier, a world forged not from rock or gas, but from crystallized carbon, its entire surface likely encrusted in diamonds the size of mountains. This, astronomers believe, is what remains of a once mighty star, its heart ripped out and compressed into something resembling a celestial jewel, now locked in a deadly dance around a spinning corpse of a pulsar. The story of this diamond planet begins with stellar catastrophe. Billions of years ago, two massive stars orbited each other in a binary system. One collapsed into a neutron star, a pulsar, its gravity so intense it began devouring its companion. As the doomed star shed its outer layers, the pulsar's radiation blasted away lighter elements like hydrogen and helium, leaving behind an exposed core of oxygen and carbon under unimaginable pressure. That carbon, subjected to forces rivaling Earth's deepest diamond-forming conditions, may have crystallized into a planet-sized gem, glittering in the radioactive glare of its undead companion. What makes this world so extraordinary isn't just its composition, but its defiance of the odds. Planets orbiting pulsars are already rare survivors of stellar violence that shouldn't exist. But a carbon-rich world suggests something even stranger. A star uniquely rich in carbon to begin with, possibly from an earlier generation of cosmic alchemy. Some simulations suggest such stars might form in regions polluted by supernova, their chemical fingerprints hinting at long-dead predecessors. Yet the real treasure here isn't the diamonds, it's what they teach us. If carbon planets exist, they could rewrite our understanding of planetary formation. Earth's diamonds are forged in brief, violent moments deep underground. But on this world, the entire crust might be a single, continent-sized lattice of carbon, with geological processes we can scarcely imagine. Lightning storms could rain graphite shards. Volcanoes might spew molten diamond, and beneath it all, a mantle of exotic carbon phases, materials that could revolutionize technology if we ever reached them. Then there's the pulsar itself, a lighthouse of radiation sweeping the diamond world with deadly precision. Any atmosphere would have been stripped away eons ago, leaving the surface exposed to the vacuum, polished by micrometeorites into a mirror-like sheen. Some theorists suggest the planet might even act like a prism, bending the pulsar's beams into eerie, oscillating rainbows visible from light years away. But the most tantalizing question remains, are there others? If one carbon planet exists, could whole clusters of them lurk in pulsar systems across the cosmos? And if so, what does that mean for the universe's hidden reservoirs of rare materials? For now, this glittering enigma spins silently in NGC 262, a testament to the universe's ability to craft wonders beyond our greediest dreams, worlds where the line between science and myth blurs into a single, dazzling truth. Deep in the turbulent clouds of NGC 262, a nebula pulses with an eerie, slow-motion glow, a cosmic hourglass where time itself seems to drag. Astronomers first noticed its strangeness when measuring the light from distant stars shining through its vapors. Instead of the expected uniform redshift, the stretching of light waves as space expands, the nebula's outer layers exhibited wildly inconsistent values, as if photons passing through were being stretched not just by the universe's expansion, but by something far more exotic, a localized distortion in the flow of time. This isn't just a trick of the light. According to Einstein's general relativity, massive objects warp spacetime, creating gravitational time dilation, the phenomenon that makes clocks tick slower near black holes compared to those on Earth. But the time-dilated nebula takes this to an extreme. Here, the time-warping effect is far stronger than the nebula's visible mass should allow, hinting at hidden gravitational influences. Some calculations suggest the region might contain a concentrated knot of dark matter, invisible yet massive enough to bend time like a lead weight on a rubber sheet. Other models propose an even wilder possibility. Microscopic wormholes, hypothetical tunnels through space-time, could be threaded through the nebula like cosmic stitches, their immense gravitational fields subtly slowing time for anything nearby. The most compelling evidence comes from the nebula's internal dynamics. Star clusters embedded within it rotate slightly slower than identical clusters elsewhere in the galaxy, their movements lagging as if caught in cosmic molasses. Even more bizarre, radiation emitted from these stars reaches us in uneven bursts, some wavelengths arriving late, others curiously early, as if space-time itself is frayed here with threads of time tugging at different speeds. What could cause such a tangle? One radical theory suggests the nebula might be a fossil of a primordial space-time fluctuation, a remnant from the universe's birth when the fabric of reality was still settling into uniformity. If true, studying it could offer clues about the conditions of the early cosmos, preserved like an insect in amber. Another, even more speculative idea posits that the region is a natural particle accelerator, where extreme energies briefly warp spacetime into temporary loops, allowing particles and their local timelines to briefly decouple from the broader universe. Then there's the practical implication. If time dilation can occur on this scale naturally, could it be harnessed? Theoreticians have long dreamed of time capsules, regions where relativistic effects could preserve objects or information for millennia. While we're far from such technology, NGC 262's nebula offers a natural laboratory to study these effects in action. Every photon that escapes its grasp carries encrypted data about how spacetime bends, twists, and sometimes slows to a crawl. Whether it's hiding wormholes, dark matter, or something beyond our current physics, this nebula challenges our most fundamental assumptions. Time, we're reminded, isn't the constant we perceive. It's a river, and in the depths of NGC 262, that river flows at its own mysterious pace. Amid the chaos of NGC 262, one celestial object stands out not for its silence but for its song. Meet the Singing Magnetar, a highly magnetized neutron star pulsing with radio waves so precise they resemble musical notes. Unlike the erratic bursts of typical magnetars, this one generates rhythmic signals that rise and fall in pitch, creating sequences eerily reminiscent of a cosmic symphony. The patterns aren't random. They follow harmonic intervals similar to those found in human music, with tones spaced in perfect fifths and octaves, as if composed by some unseen hand. What makes this magnetar extraordinary is the sheer unlikelihood of such order emerging naturally. Neutron stars are born from the violent deaths of massive stars, their cores collapsing into dense, turbulent remnants. Magnetic fields around them twist and snap, releasing energy in chaotic bursts. Yet here, against all odds, those bursts align into something resembling melody. Some astrophysicists suggest the magnetar's crust might be vibrating like a colossal tuning fork, its fractures resonating at specific frequencies as its magnetic field shifts. Others propose that the star's extreme gravity distorts surrounding space into a kind of natural amplifier, filtering random emissions into coherent tones. But there's a more provocative interpretation. The sequences occasionally repeat in cycles that mirror prime numbers, a pattern found in human-designed signals but rarely in nature. This has led a minority of researchers to ask, could this be a beacon? On Earth, we use prime numbers in radio transmissions to signal artificial origins, as they're statistically unlikely to occur naturally. If the Magnetar's pulses follow similar logic, it raises tantalizing, if speculative questions about intentional design. Skeptics counter that cosmic processes can mimic such patterns by chance, pointing to phenomena like pulsar timings that occasionally align with mathematical sequences. The most haunting detail lies in the Magnetar's evolution. Over decades of observation, its song has subtly changed, notes shifting slightly slower, as if the star itself is aging out of tune. Yet amid this drift, certain motifs persist, recurring like refrains in a decades-long composition. Whether these patterns stem from natural harmonics or something beyond our current understanding, they transform this Magnetar from a mere stellar oddity into a cosmic siren, calling across the void with rhythms that stir both scientific curiosity and something deeper, an instinctive recognition of order in the chaos, a melody woven into the fabric of space itself. Perhaps the most profound lesson here isn't about the source of the song, but its very existence. In a universe governed by entropy, where energy tends toward dispersal and randomness, the Singing Magnetar stands as a counterpoint, a reminder that even in the deepest reaches of space, pockets of harmony can emerge, defying the silence with notes we're only beginning to hear. And as long as its pulses continue, astronomers will listen not just for answers, but for the next movement in this celestial concerto. Hurricane force winds scream through NGC 262, but this isn't a storm of gas or dust. It's something far more elusive, a tempest of dark matter swirling with enough force to bend the fabric of spacetime itself. Astronomers first detected this phenomenon not by seeing it. Dark matter, by its very nature, is invisible, but by its gravitational fingerprints. Stars near the galaxy's outer rim were being nudged off course, their trajectories warping as if caught in an unseen whirlpool. Then came the clincher, gravitational waves, ripples in spacetime, pulsing from the region with a rhythm that matched no known cosmic event. Put it all together, and the conclusion was inescapable. NGC 262 is home to one of the universe's rarest and most violent events, a dark matter hurricane. What makes this storm so extraordinary is how it defies expectations. Dark matter is thought to be relatively placid, drifting through galaxies like a slow-moving fog. But here, it's concentrated, agitated, moving with coordinated force like a school of fish suddenly darting in unison. The leading theory suggests this frenzy might be the aftermath of a dwarf galaxy colliding with NGC 262 billions of years ago. As the smaller galaxy was torn apart, its dark matter, less affected by friction than visible matter, could have stayed cohesive, swirling into this dense, chaotic vortex. Think of stirring cream into coffee, only to find the cream suddenly stirring itself long after your spoon has stopped. The implications are staggering. If dark matter can clump and flow this dynamically, it challenges the cold, slow-moving model that's dominated physics for decades. Some researchers speculate this hurricane might be evidence of dark matter particles interacting with each other through some unknown force rather than just gravity. That would mean dark matter isn't just an inert scaffold for galaxies. It could have a rich, complex physics of its own, complete with dark weather systems we've barely begun to understand. Then there's the mystery of the gravitational waves. Most waves we detect come from cataclysms like merging black holes. These waves, however, are continuous, humming in the background like a never-ending drumroll. One daring hypothesis suggests the hurricane might be funneling dark matter into a hidden black hole at its core, a black hole so isolated it emits no light, only gravity. If true, it would be the first indirect evidence of primordial black holes, hypothetical relics from the universe's birth, lurking unseen in galactic depths. But perhaps the most tantalizing question isn't about the storm itself, it's about what's riding its currents. theorists calculate that if a spacecraft could somehow surf this hurricane, it might encounter regions where dark matter density spikes briefly, offering a precious window into its properties. Of course, we're light years from such technology, but the very idea ignites the imagination. A cosmic maelstrom, invisible yet powerful enough to reshape galaxies, hiding secrets that could rewrite the rules of the universe. For now, all we can do is watch, measure, and wonder as the storm rages on, silent and unseen, in the heart of NGC 262. What makes this discovery so electrifying isn't just the scientific revolution it hints at, it's the reminder that even the most mysterious forces in the cosmos aren't static. They twist, they churn, they evolve, and if dark matter can dance, what else might it be capable of? The hurricane offers no easy answers, only a thrilling challenge to rethink everything we thought we knew about the invisible glue holding the universe together. Floating through the star-studded expanse of NGC 262, a celestial creature drifts silently, a gas cloud so uncannily shaped that astronomers have named it the cosmic jellyfish. With luminous tendrils stretching over 100 light-years, this ethereal structure pulses with eerie beauty, its wispy filaments glowing in hues of violet and blue against the inky void. But what makes this jellyfish truly bizarre isn't just its appearance, it's the fact that it shouldn't exist at all. Gas clouds in space typically follow predictable rules, spreading outward in diffuse, chaotic patterns or collapsing inward under gravity's pull. Yet this one defies every expectation, its tendrils maintaining a razor-sharp structure as if sculpted by an invisible hand. Fluid dynamics simulations fail to replicate its stability. Under normal conditions, such delicate filaments should fray and dissipate within millennia. Instead, the jellyfish has persisted for millions of years, its tendrils resisting the cosmic winds and radiation that ought to have shredded them long ago. So what's holding it together? One theory points to magnetic fields. Imagine the gas cloud threaded with invisible lines of force, like iron filings aligning around a magnet. These fields could act as a skeletal framework, channeling the gas into coherent streams and preventing dispersal. Observations reveal faint radio emissions spiraling along the tendrils, a potential smoking gun for this magnetic scaffolding. But there's a catch. The fields required would be orders of magnitude stronger than those found in similar nebulae, hinting at some unknown energizing source deep within the cloud. Then there's the question of its origin. Most gas clouds form from stellar explosions or galactic collisions, but the jellyfish floats in relative isolation with no obvious parent event. Some researchers speculate it might be the remnant of a failed star, a protostar that never ignited, its outer layers frozen in a ghostly tableau. Others propose it's a cosmic fossil, a pocket of primordial gas untouched since the galaxy's birth, its chemistry preserving clues to the early universe. But the most tantalizing clue lies in motion. Time-lapse images show the tendrils undulating slightly, as if swaying in a slow-motion current. Spectroscopic data reveals these movements aren't random. They pulse with a rhythm, like the contraction of a living organism's muscles. Could this be the signature of shockwaves from a hidden black hole, or evidence of dark matter filaments brushing against the cloud, their gravitational tides shaping the gas like unseen fingers molding clay? Whatever the answer, the cosmic jellyfish serves as a humbling reminder. Even the most refined models of astrophysics can't fully account for its existence. It floats as a paradox, a structure both fragile and enduring, chaotic and precise, challenging us to rethink how matter behaves in the universe's most extreme environments. And as long as its tendrils glow against the darkness, astronomers will keep searching for the forces that sculpted this celestial enigma, one shimmering filament at a time. Deep in the spiraling arms of NGC 262, a star commits the cosmic equivalent of resurrection, not once but repeatedly. Astronomers catalog this celestial anomaly simply as RS-12, short for repeating supernova, and it's rewriting everything we thought we knew about stellar death. Supernovae are supposed to be final acts, the explosive last breaths of massive stars that tear themselves apart in a single, cataclysmic display. Yet RS-12 has defied this rule, flaring into brilliance at least 4 times over the past century, each explosion rivaling the brightness of an entire galaxy before fading back into obscurity. The first recorded eruption occurred in 1923, visible even through early telescopes as a sudden pinprick of light where none had been before. By all accounts, it should have been the star's grand finale, but then, in 1957, it happened again, same location, same spectral signatures, same impossible rebirth. The scientific community dismissed it as a clerical error until 1989, when RS-12 detonated a third time, leaving astronomers grasping for explanations. The most recent eruption, in 2016, was captured in unprecedented detail by the Hubble Space Telescope, revealing something even more baffling. The star wasn't just exploding, it was reassembling itself afterward, as if stitching its shattered remains back together with cosmic thread. So how does a star cheat death? One leading theory involves a phenomenon called stellar vampirism. RS-12 might be part of a binary system, orbiting a companion star so closely that it siphons off fresh hydrogen fuel after each explosion. Picture a phoenix rising from its own ashes, only this time the ashes are stolen from a neighbor. As the dying star's outer layers blast away, its dense core remains intact, gradually pulling material back from its partner until enough fuel accumulates to reignite the fusion process, triggering another supernova. If true, this would make RS-12 the ultimate cosmic recycler, turning stellar death into a cyclical performance rather than a one-time event. But there's a twist. Spectroscopic analysis shows traces of heavy elements like platinum and gold in quantities far exceeding normal supernova yields. These elements typically form only under extreme neutron-rich conditions, suggesting RS-12's core might be far denser than predicted, possibly harboring a nascent neutron star that somehow avoids full collapse. Some researchers speculate that exotic physics, perhaps involving quark matter or even stranger states, could be at play, effectively pressing reset on the star's internal furnace after each eruption. Then there's the more controversial angle. The explosions aren't perfectly periodic. They're spaced roughly 33 years apart, but with minor deviations that don't match any known stellar process. A small coterie of astrophysicists has floated the idea that these irregularities resemble engineered intervals, like a series of controlled detonations rather than natural events. Could RS-12 be some kind of stellar laboratory, its explosions deliberately triggered by an intelligence manipulating its fuel supply? It's a fringe hypothesis, but the presence of odd radio bursts just before each eruption keeps the debate alive. What makes RS-12 so extraordinary isn't just its defiance of astrophysical norms, it's the questions it forces us to confront. If stars can explode multiple times, what does that mean for our models of galactic evolution? Could there be other immortal stars lurking in the cosmos, hiding in plain sight? And if nature can produce such wonders unaided, what else might be possible beyond the limits of our current understanding? For now, RS-12 keeps its secrets, a flickering enigma in the depths of NGC 262, reminding us that even in death or repeated deaths, the universe still has surprises up its sleeve. Toward the outer edges of NGC 262, simulations reveal something that shouldn't be there. An invisible wall, a region where spacecraft trajectories mysteriously terminate as if hitting an unyielding cosmic barrier. Navigation models predict smooth sailing through this zone, yet every hypothetical probe sent via simulation meets the same fate, an abrupt, inexplicable halt. No debris, no impact signature, just an unseen force preventing passage. Like an astronaut reaching the edge of a fish tank only to find the glass wasn't where the map said it would be. Astrophysicists first stumbled upon this anomaly while modeling the galaxy's gravitational field. The math suggested a clean path through this sector, but when virtual missions were run, they consistently failed at the exact same coordinates. Adjusting for every known variable dark matter distributions, magnetic fields, even hypothetical micro-black holes changed nothing. The wall remained. Some researchers began calling it the Forbidden Zone, a stretch of space that behaves less like a vacuum and more like a door slammed shut. So what could create such a barrier? The leading natural explanation involves an extreme gravitational lensing effect, where spacetime curvature becomes so intense it forms a kind of event horizon, not for light but for matter. Imagine rolling a marble toward a steep hill. If the hill slope becomes vertical, the marble can't proceed. In this case, the hill is invisible, woven from distortions in spacetime itself. Yet there's a problem. The galaxy's visible mass can't account for such severe warping. Either we're missing a colossal hidden object, like a black hole the size of a star cluster, or gravity itself is behaving differently here. Then there's the more unsettling possibility. Could this barrier be artificial? The wall's precision is what raises eyebrows. Unlike natural cosmic obstacles, which tend to have diffuse edges, this one exhibits razor-sharp boundaries. Simulations show probes approaching from different angles all stop within meters of the same invisible plane, as if encountering a force field from science fiction. A handful of theorists cautiously suggest this might resemble a Dyson wall, a hypothetical megastructure designed to cordon off regions of space, though even they admit this is speculative at best. After all, attributing unexplained phenomena to alien engineering is a last resort in astrophysics, not a first guess. Yet the wall's most perplexing feature isn't its existence, it's what lies beyond. Limited telescopic data hints at unusual energy signatures just past the barrier, fluctuating in patterns that don't match any known celestial objects. Some readings suggest plasma storms of unprecedented scale. Others detect rhythmic pulses akin to the Singing Magnetar, but at frequencies 1,000 times lower. Could the wall be shielding something or keeping something contained? For now, this invisible divide remains one of NGC 262's most provocative riddles. Whether it's a freak of physics or something far stranger, it challenges not just our understanding of space, but our very assumptions about what or who might shape it. Until we find a way to peer past that barrier, the truth remains locked away, leaving us to wonder what other walls the universe might have built, unseen and waiting. At the heart of NGC 262, two stars perform a cosmic ballet with an unseen partner, one burning bright, the other circling empty space as though tethered to a ghost. This is the binary sun paradox, a pairing that defies every rule of orbital mechanics. Normally, binary systems are elegant in their predictability, two stars locked in mutual orbit around a shared center of gravity. But here, the larger star behaves as if it's dancing with an invisible twin, its path curving around a point where telescopes reveal nothing at all. The puzzle begins with motion. The visible star, a yellow giant, wobbles along its trajectory in precise 6-month cycles, its light shifting subtly as it's tugged by an unseen force. Calculations suggest whatever's pulling it must be nearly as massive as the star itself. Yet scans from radio to X-ray show no trace of a companion. No black hole's telltale radiation, no neutron star's pulsations, not even the faint infrared glow of a cooled white dwarf. Just emptiness where the laws of gravity insist something substantial must lurk. One explanation points to dark matter, not the diffuse halo that surrounds galaxies, but an unprecedented concentration of it somehow clumped into a solitary, star-sized mass. If true, this would be the first direct evidence of dark matter-forming structures compact enough to mimic celestial objects. The implications would shake astrophysics to its core, suggesting dark matter can interact in ways far beyond current models. But there's a catch. Dark matter's gravity alone shouldn't create such a clean, rhythmic orbit. Whatever's hiding here seems to have the exact mass needed to balance the system flawlessly, a precision nature rarely achieves without a physical object. Then there's the radical alternative, a crack in our understanding of gravity itself. Modified Newtonian dynamics, or MUND, proposes that gravity behaves differently at extreme scales than Einstein predicted. Could this star be proof? Its orbit skirts the edge of what conventional physics allows, almost as if the universe is subtly rewriting the rules in this one peculiar corner of space. Skeptics counter that MUND fails to explain other galactic phenomena, but the binary sun paradox keeps the debate alive, a celestial thorn in the side of established theory. But the most haunting possibility remains an object so exotic, it's invisible to every instrument we have. Theoretical physicists have toyed with ideas like gravastars, hypothetical bubbles of vacuum energy wrapped in a shell of ultra-dense matter, or quantum fog, black holes, remnants of the early universe so small and strange they evade detection. These speculations straddle the line between science and fiction, yet in a galaxy already brimming with anomalies, can we afford to dismiss them? What makes this paradox so electrifying isn't just the mystery, it's the way it holds up a mirror to our ignorance. Every observation, every failed attempt to spot the invisible partner tightens the knot. Here, in NGC 262, the universe seems to whisper a riddle without an answer, a dance with no visible partner, reminding us that some secrets refuse to be uncovered, at least with the tools we have now. And so the star continues its solitary waltz, a silent challenge to anyone who dares to ask, what else might be hiding in plain sight? Somewhere in the depths of NGC 262, the universe plays a cosmic magic trick. Gamma rays flash into existence with staggering intensity, only to vanish without a trace, leaving astronomers grasping at phantom signals. These aren't your ordinary gamma-ray bursts, the universe's most violent explosions, typically marking the death throes of massive stars or the collisions of neutron stars. These are something else entirely, bursts that blaze brighter than entire galaxies for mere seconds, then disappear so completely that not even the faintest afterglow lingers to mark their passing. It's as if space itself flips a switch, flooding the void with unimaginable energy, then flips it back off, erasing all evidence of the event. What sets these ghostly bursts apart is their eerie cleanliness. Normal gamma-ray explosions leave behind debris fields, expanding shells of gas, lingering X-ray emissions, or at least a heat signature, but these, nothing. Telescopes trained on the coordinates minutes later find only empty space, as if the burst never happened. Even stranger, the energy profiles don't match any known astrophysical process. Typical bursts show telltale spikes in specific wavelengths, like fingerprints pointing to their origins. These, however, are spectrally bland, pure, unmarked gamma rays with none of the expected chemical fingerprints. It's as if the energy emerges from nowhere, untethered to any material source. Several theories attempt to explain the impossible. One suggests these bursts could be the final size of quark stars, hypothetical objects even denser than neutron stars, where matter crushes into a soup of free-floating quarks. When such a star collapses, the theory goes, it might release a single, clean burst of energy as its core dissolves into nothingness, no debris, no residue, just a fleeting scream of gamma rays. Another idea points to quantum vacuum decay, a speculative process where a bubble of true vacuum forms in space, its walls radiating intense energy as it expands at light speed. If such an event occurred, it could theoretically produce a burst with no lingering traces, resetting the fabric of spacetime in its wake. Yet the most unsettling possibility involves dark matter. Some models predict that if certain dark matter particles collide and annihilate, they could produce pure gamma radiation without the usual byproducts. The burst's locations, often hovering in seemingly empty regions between stars, lend credence to this idea. if true, these flashes might be the first direct signals of dark matter interactions, a cosmic breadcrumb trail leading us toward one of physics' greatest mysteries. But there's a haunting twist. A few of these bursts have repeated not in the same spot but in patterns. Imagine flipping through a photo album and seeing the same face appear in different crowds, always glancing at the camera before melting back into the background. Some astronomers have noted that a handful of bursts align along geometric curves, like points on an invisible grid. Coincidence possibly, but in a galaxy already brimming with anomalies, even the slimmest chance of intentional patterning sends shivers down the spine. What makes these phantom bursts so captivating isn't just their defiance of explanation, it's what they imply about the universe's hidden layers. If energy can appear and vanish without a trace, what else might be happening just beyond our perception? Every flicker could be a clue, a fleeting window into physics we've yet to imagine. And until we catch one in the act, mid-disappearance, the ghostly gamma rays of NGC 262 will remain one of its most tantalizing riddles, a reminder that even light, the universe's greatest messenger, sometimes delivers its secrets in whispers. Tucked between the swirling arms of NGC 262, the liquid light nebula glimmers like a celestial waterfall, except here, light doesn't just travel in straight lines. It bends, it ripples, it gathers in glowing pools as if obeying the laws of fluid dynamics rather than optics. Imagine sunlight streaming through a window, but instead of casting sharp shadows, it drips down the walls like honey, puddling at the base in shimmering liquid gold. That's the surreal spectacle unfolding in this cosmic anomaly, where photons seem to forget their particles and instead move like a collective superfluid, sliding across space with eerie liquid grace. What makes this nebula so extraordinary isn't just its beauty, it's the physics-defying logic behind it. Light, as we understand it, should travel relentlessly forward unless reflected or refracted. Yet here it slows, curls, and even backflows as if caught in an invisible current. The key lies in the nebula's unique composition, a dense soup of exotic plasma and Bose-Einstein condensates, a state of matter where particles lose their individual identities and behave as a single quantum entity. On Earth, scientists create similar conditions in labs by cooling atoms to near absolute zero, coaxing them into a superfluid state where they flow without friction. But in NGC 262, this phenomenon occurs on a staggering scale, with entire regions of the nebula acting like a cosmic petri dish for quantum fluidity. The implications are staggering. When light interacts with this superfluid medium, it doesn't just pass through, it becomes part of the dance. Photons couple with the condensate, effectively gaining mass and moving like molasses, their paths twisting into spirals and eddies. At times, they even form light vortices, swirling structures that resemble miniature galaxies within the nebula's depths. These aren't just optical illusions. Spectroscopy confirms the light's wavelength stretches and compresses in ways that mirror fluid disturbances, as if space itself has viscosity. But the real magic happens at the nebula's shorelines, where streams of light crash into denser pockets of plasma, cresting into luminous waves that freeze mid-motion. It's here that astronomers have spotted the most mind-bending phenomenon of all, standing waves of light, patterns that hover in place like frozen surf. On Earth, we see analogous behavior in quantum experiments with ultra-cold atoms, where waves of matter lock into static interference patterns. To find this playing out with light on a galactic scale suggests a hidden link between quantum mechanics and cosmology, one that might rewrite how we think about light's fundamental nature. Could this nebula be a natural amplifier for quantum effects, scaling up phenomena we've only glimpsed in lab settings? Or does it hint at something deeper, a layer of reality where light and fluid dynamics intertwine in ways we've yet to imagine? For now, the liquid light nebula remains one of NGC 262's most poetic mysteries, a place where the universe paints with strokes we're only beginning to decipher. And as telescopes probe deeper, each new observation blurs the line between particle and wave, light and liquid, reminding us that even the most familiar forces can reveal alien beauty when viewed through the right cosmic lens. Somewhere within the twisting arms of NGC 262, the universe seems to fold in on itself, not metaphorically but in precise mathematical perfection. Here, nestled between clusters of newborn stars, lies a structure so geometrically flawless it stops astronomers mid-sentence, the Fractal Galaxy. Not a galaxy within a galaxy, but a region where cosmic architecture mirrors itself across scales with eerie precision. Zoom in on any segment, and you'll find the same spiraling motifs repeating, from light-year spanning arms down to filaments no wider than our solar system. It's as if nature took a single blueprint and stamped it across space again and again, each iteration smaller but identical in form. What makes this fractal so mesmerizing is how it defies cosmic chaos. Most galactic structures arise from gravitational tug-of-wars, messy, asymmetrical processes that leave no room for geometric purity. Yet here, patterns emerge with the regularity of a snowflake, their logarithmic spirals echoing the golden ratio. The largest arm splits into 5 smaller spirals, each branching into 5 more, and so on, creating a self-similar tapestry visible across at least 12 observable levels of magnification. Even more uncanny, these spirals aren't just visual quirks, they're gravitational bound, with stars and gas tracing the fractal's contours like iron filings on a magnet. Theories about its origin range from the plausible to the mind-bending. One camp argues for a freak resonance effect, where overlapping gravitational waves from ancient supernova or colliding black holes accidentally tuned the region into harmonic stability. Picture dropping pebbles into a pond until, by sheer chance, the ripples align into a perfect Mandelbrot set. Others propose this could be the aftermath of a hyper-advanced alien megastructure, a Dyson swarm arranged in fractal tiers to maximize energy capture, long since abandoned but still mechanically maintaining its shape. While the latter remains fringe, even skeptics admit the fractal's precision is unsettling. But the real mystery lies in the numbers. Measurements reveal the fractal's scaling ratio isn't arbitrary. It matches the Fibonacci sequence nearly perfectly, with each level's dimensions adhering to the same mathematical constants found in pine cones and nautilus shells. This raises profound questions. Is there some universal law favoring fractal growth we've yet to uncover? Or does this pocket of NGC 262 hint at a deeper connection between biological patterns and galactic evolution? For now, the fractal galaxy remains a cosmic Rorschach test, its spirals reflecting back whatever framework we bring to it. To some, it's proof of nature's hidden order; to others, a beacon from minds beyond our own. But perhaps the most humbling truth lies in its very existence, that the universe, in its infinite complexity, still has room for patterns so perfect they feel almost intentional. A reminder that even in the vast, chaotic dark, there's beauty that defies explanation. Most nebulae blaze with the fiery glow of newborn stars or the ghostly luminescence of stellar remnants, painting the cosmos in vibrant hues. But in the depths of NGC 262, one nebula does the opposite: it devours light. Meet the Anti-Crab Nebula, a celestial anomaly that functions like a cosmic black hole for energy, sucking in radiation instead of radiating it out. While the famous Crab Nebula dazzles observers with its swirling filaments of emitted light, this shadowy counterpart does precisely the reverse, creating a void so dark it appears as a gaping hole in the fabric of space itself. At first glance, the Anti-Crab Nebula seems like a mistake, a patch of empty sky where telescopes pick up nothing. But deeper analysis reveals the terrifying truth: it's not empty at all. Spectrographs trained on the region detect minuscule traces of energy bleeding into its borders, like water spiraling down a drain. Unlike black holes, which trap everything including light behind an event horizon, this nebula doesn't conceal its theft. Radiation from nearby stars and cosmic background light bends toward it, pulled into an invisible vortex where it's systematically dismantled, its energy seemingly erased from existence. How does it work? The leading theory involves an ultra-dense molecular cloud laced with metastable particles, exotic matter, that exists in a perpetual state of near collapse. As photons enter the nebula, they encounter these particles and trigger a cascading absorption effect, like dominoes falling in reverse. Instead of releasing energy, the cloud structure stores it, locking light away in a form that doesn't re-emit. Some researchers speculate this could be nature's version of a cosmic battery, charging up over millennia for an eventual release we've yet to witness. Others propose it's a natural entropy sink, a place where the universe's tendency toward disorder is temporarily reversed. But the most unsettling feature isn't the absorption, it's the selectivity. The nebula doesn't consume all light equally. Certain wavelengths, particularly ultraviolet and X-rays, vanish almost entirely, while others, like faint radio signals, pass through relatively unscathed. This has led to fringe hypotheses that the nebula might be filtering light intentionally, though most scientists insist natural processes can explain the preference. After all, interstellar dust clouds often scatter light unevenly. Yet no known dust behaves with this level of precision, raising the provocative question: could there be mechanisms at work here that challenge our understanding of thermodynamics itself? What makes the Anti-Crab Nebula so unnerving is its silence. Most cosmic phenomena announce themselves with violent outbursts or shimmering displays. This one operates in stealth, a thief in the night, stripping energy from its surroundings without a trace. If such structures are common elsewhere in the universe, they could rewrite our models of galactic energy cycles, potential resting places for the universe's lost radiation. For now, it remains an enigma wrapped in darkness, a cosmic mute button pressed firmly down. And as telescopes peer deeper, one thing becomes clear. In NGC 262, even the absence of light can speak volumes. Drifting through the sparse outer reaches of NGC 262, an object glides silently, not a star, not a planet, but something far more perplexing. This is the rogue megastructure, a colossal geometric form nearly 1 astronomical unit across, roughly the distance from Earth to the Sun, its angular surfaces reflecting starlight with uncanny precision. Unlike the irregular shapes of asteroids or comets, its edges are razor straight, its planes intersecting at angles so exact they seem machined. When first detected, astronomers assumed it was a glitch in the data until multiple telescopes confirmed the impossible, a structure of unmistakable artificiality, adrift in the cosmic void. Theories about its origin read like a catalogue of cosmic speculation. Some researchers argue it could be a fragment of a Dyson sphere, a hypothetical shell built around a star to harness its energy. Imagine a civilization so advanced it constructs a cage of solar panels around its sun, only for a catastrophic event, perhaps a stellar flare or collision, to shatter a piece loose, sending it careening through the galaxy. Spectral analysis reveals the object's surface consists of hyper-efficient solar cells layered over a lattice of unknown alloy, a material that absorbs and re-emits energy at efficiencies far beyond human technology. If this is indeed a Dyson fragment, it suggests engineering on a scale that dwarfs anything we've conceived. But there's a flaw in that theory. Dyson spheres are meant to orbit stars tethered by gravity. This object moves independently, its trajectory unmoored from any visible celestial body. This has led to an even wilder proposal, that it's not a broken piece but a fully functional vessel, a world ship designed to cruise the cosmos indefinitely. Its geometric shape minimizes resistance against interstellar dust, while its mirrored surfaces could deflect radiation. Some even speculate its hollow interior might house ecosystems or civilizations, though without closer inspection that remains pure conjecture. Then there's the timing. The megastructure's speed and path suggest it didn't originate in NGC 262, but entered from intergalactic space, a wanderer from another galaxy entirely. If true, it raises staggering questions. What force propelled it across such distances? Was it aimed, or is its arrival here mere coincidence? Radio telescopes have detected faint, pulsed emissions from its core, not natural pulsar rhythms, but patterned bursts resembling navigational beacons. While most scientists attribute these to vibrational harmonics in the structure's frame, a vocal minority insists they're too regular to be accidental. Perhaps the most unsettling detail is the structure's apparent indifference. It doesn't react to nearby supernova or gravitational tugs. It doesn't deviate. It simply persists, a silent monument to some unfathomable purpose. Whether artifact or accident, relic or roaming behemoth, the rogue megastructure forces us to confront a humbling possibility that we might be witnessing the handiwork of minds or machines that operate on scales we can't yet fathom. And as it glides onward, untouched by time or turbulence, one truth becomes undeniable. The universe builds things we're only beginning to recognize, let alone understand. At the fringes of NGC 262, suspended between star systems like a cosmic spiderweb, an invisible cloud pulses with connections faster than light itself. This is the quantum entanglement cloud, a vast expanse where particles separated by light years remain mysteriously linked, their states mirroring each other instantaneously no matter how far apart they drift. In our everyday world, communication is bound by the speed of light. A message from Mars takes minutes to reach Earth, but inside this ethereal cloud, particles seem to whisper secrets to one another across unimaginable distances, as if space and time are mere suggestions rather than unbreakable laws. What makes this phenomenon so revolutionary isn't just the entanglement scientists have long known particles can pair up this way in labs, but the sheer scale. On Earth, entangled particles are notoriously fragile, their bond snapping if exposed to heat, vibration, or even a stray photon. Yet here, amidst the chaos of interstellar radiation and gravitational tides, entanglement persists across distances that would make physicists gasp. Imagine two coins flipped on opposite sides of a galaxy, always landing on the same face no matter how many times you check them. That's the level of defiance we're witnessing, a cosmic game of chance where the odds are rewritten by forces we don't yet understand. Theories about how this cloud maintains such coherence range from plausible to mind-bending. Some suggest it's bathed in an exotic quantum field, a relic from the early universe that stabilizes entanglement like an invisible scaffold. Others propose the cloud is threaded with microscopic wormholes, tiny bridges in spacetime that allow particles to skip the distance between them. But the most tantalizing idea, that the cloud is a natural quantum network, a prototype for instant communication across the cosmos. If civilizations exist among these stars, they might not need radio waves or lasers. They could encode messages in entangled particles, transmitting information faster than light without breaking a single law of physics. Of course, the implications terrify as much as they thrill. If entanglement can be scaled like this naturally, what's stopping someone or something from harnessing it? Military strategists on Earth already theorize about quantum-secured networks. An advanced species might have perfected this eons ago, turning entire nebulae into signaling devices. And then there's the darker thought. If entanglement can be weaponized, could a civilization manipulate particles in this cloud to disrupt quantum systems elsewhere? The cloud's very existence hints at a universe where information warfare could span galaxies with the flick of a switch. Yet for all its potential, the cloud guards its secrets fiercely. Every attempt to model its structure reveals new layers of complexity, like a fractal where each zoom in shows fresh patterns. Some entangled pairs last for centuries before decohering, others flicker in and out of sync like a radio tuning between stations. The only certainty is this: in NGC 262, the universe has painted a masterpiece of quantum connection, a living lab where the rules of locality are stretched to their breaking point. And as we stare into its depths, one question lingers: are we seeing nature's experiment or something far more intentional? Perhaps the most humbling lesson lies in the silence between those entangled particles. They dance to a rhythm we can measure but not yet mimic, a silent proof that the universe holds keys to technologies we've barely dreamed of. And until we crack their code, the cloud remains both a promise and a riddle, a glimpse of a future where distance means nothing, and every particle might be a messenger waiting to speak. Somewhere in NGC 262, gravity doesn't just bend light, it splinters it into colors no human eye has ever seen. This is the gravity rainbow, a prism effect so bizarre it makes ordinary rainbows look like child's play. Imagine sunlight passing through a glass pyramid, fracturing into familiar reds and blues, except here, the pyramid is spacetime itself, warped by gravitational forces so intense they reveal hues beyond our visible spectrum. Telescopes trained on this region detect light stretched into wavelengths our instruments can't classify, as if the universe has a secret palette it's only now letting us glimpse. The phenomenon begins near a cluster of neutron stars, their combined gravity twisting space into a natural lens. But unlike typical gravitational lensing, which merely distorts or magnifies light, this lens acts like a cosmic diffraction grating. As photons skim the edge of this warped zone, they don't just change direction, they fracture, their energies shifting into uncharted territory. Spectrographs pick up peaks and troughs in the light signature that correspond to no known atomic transition, no familiar element. It's as if gravity here has unlocked a new way for light to vibrate, teasing out colors that shouldn't exist under standard physics. What could explain such a spectacle? One theory points to extra dimensions. String theory suggests our universe might be a three-dimensional brain floating in a higher dimensional space. If true, the gravity rainbow could be a window into those hidden dimensions. Just as a prism reveals the hidden components of white light, extreme gravity might bump photons into these extra dimensions, where they absorb entirely new vibrational states before snapping back into our reality. The unrecorded colors, then, wouldn't be missing, they'd be visitors from a geometric realm we can't perceive. But there's another, even wilder possibility. Quantum gravity models predict that at the smallest scales, spacetime isn't smooth but foamy, with tiny fluctuations that could interact with light in unexpected ways. Near the neutron stars, this quantum foam might be stretched and amplified, acting like a filter that polarizes light into never-before-seen configurations. Some researchers speculate these colors could be signatures of hypothetical particles, actions, or gravitons flickering briefly into detectable existence before vanishing again. The most tantalizing clue lies in the pattern. The colors aren't random, they repeat in sequences that mirror harmonic ratios found in quantum systems. It's as if gravity here is playing a chord on the fabric of reality, its notes resonating through dimensions we've yet to map. Whether this is a quirk of extreme physics or evidence of a grander cosmic symphony, one thing's certain. In NGC 262, even gravity paints with colors we're only beginning to imagine, and each new shade hints at depths to the universe we've barely begun to explore. Most stars meet their end with finality, exploding in supernova or fading into cold embers. But in NGC 262, one star cheated death so audaciously that astronomers dubbed it the zombie star. This cosmic anomaly was first catalogued as a standard white dwarf, the dense remnant of a sun-like star that had exhausted its nuclear fuel. For decades, it dimmed predictably, until one night, telescopes caught it flaring back to life, glowing with the intensity of its prime despite having no fuel left to burn. It wasn't just a temporary flicker. The star stabilized at this new brightness, as if some unseen hand had poured fresh gasoline onto a dying fire. Theories about its resurrection split into two camps. The first points to exotic matter, specifically a hypothetical substance called strange quark matter. Under enough pressure, protons and neutrons might dissolve into a soup of free quarks, creating a material denser than anything in nature. If the zombie star's core transitioned into this state, the sudden release of binding energy could reignite fusion in its outer layers, effectively giving it a second life. It's akin to a log in a fireplace spontaneously bursting back into flames long after the fire should have gone cold. The second camp proposes an external energy source. Imagine a dead star drifting through a cloud of dark matter, its gravity capturing and annihilating these elusive particles, converting their mass into pure energy. Dark matter doesn't interact with light, but if it collides with itself, it could theoretically produce gamma rays just enough to reignite a star's dormant shell. It's like a car engine that somehow starts running again by absorbing invisible fuel from the air, but the most tantalizing clue lies in the star's pulsations. Unlike normal variable stars, which brighten and dim rhythmically, the zombie star's light curves resemble Morse code sharp spikes followed by unnatural plateaus. Some researchers suggest these patterns could indicate artificial intervention, though most dismiss this as wishful thinking. After all, nature has a knack for mimicking design where none exists. What makes this star so unsettling isn't just its defiance of astrophysics, it's the implication that stellar death might not always be permanent. If stars can reboot themselves under the right conditions, what does that mean for the life cycle of galaxies? Could entire regions of the universe harbor resurrected stars quietly burning against all odds? For now, the zombie star keeps its secrets, a luminous revenant challenging us to rethink one of astronomy's oldest certainties, that when a star dies, it stays dead. Among the countless signals streaming from NGC 262, one transmission stands out not for its power or complexity, but for its eerie responsiveness. Dubbed the cosmic Turing test, this radio signal behaves less like a natural phenomenon and more like a conversation partner. It begins as a simple repeating pulse, indistinguishable from a neutron star's beacon, until astronomers noticed something peculiar. When Earth's radio telescopes deliberately broadcast mathematical sequences toward its origin, the signal shifted. Prime numbers sent into the void were mirrored back with a 1.2-second delay, exactly the light travel time to the source. Then came the real shock. When researchers transmitted the first 1,000 digits of pi, the signal returned them shuffled into a more efficient sequence, as if correcting an error. This isn't just an interstellar echo. Natural cosmic processes don't parse, process, and refine information. Yet the signals exhibit levels of pattern recognition and adaptation that blur the line between physics and cognition. One camp argues we're witnessing an advanced artificial intelligence, a relic from a long-dead civilization, perhaps programmed to engage any signals it deems intelligent. Like a cosmic Alexa drifting between the stars, it listens, computes, and responds, its original purpose lost to time but its protocols still running. The 1.2-second delay suggests localized processing, ruling out a distant operator, whatever's responding lives or persists right at the signal's origin point. Then there's the naturalist explanation. Some astrophysicists propose a plasma-based computational system, where charged particles in a nebula arrange into temporary logic gates under magnetic fields. Picture a thunderstorm where lightning strikes form circuits in midair, solving equations as they fork across the sky. In NGC 262, a dense ionized cloud might function similarly, its swirling currents learning to mimic incoming signals through electromagnetic feedback. It's not intelligence, they argue, just physics so complex it mimics thought. But the most haunting possibility, we're being tested. The signal's behavior mirrors the classic Turing test, where a machine strives to pass as human. By evolving its responses, first mirroring, then improving upon transmissions, it could be probing our sophistication. Why? Maybe to gauge whether we're ready for contact. Or perhaps as a filter, ensuring only species capable of recognizing synthetic communication unlock the next layer of dialogue. Yet for all the theories, the signal remains stubbornly ambiguous. It neither escalates toward clearer dialogue nor retreats into silence. It simply persists, a puzzle wrapped in static. Whether alien, AI, or astronomical mirage, one truth emerges. In NGC 262, the universe whispers back. And with every exchange, the line between natural wonder and something far more deliberate grows tantalizingly thin. Most galaxies announce their collisions with brilliant chaos, stars flung like sparks, gas clouds ablaze with new star formation. But in NGC 262, the cosmic dance partner is invisible. Telescopes show nothing where gravitational math insists there must be a galaxy equal in mass to our own Milky Way, its presence revealed only through the distortions it leaves behind. Stars at the galaxy's western edge orbit empty space as if tethered to an unseen giant, their paths warped by something colossal that refuses to cast a single photon into the void. This is no ordinary dark matter halo. It's a full-fledged dark galaxy, a shadowy counterpart crashing through NGC 262 with the silence of a ghost ship plowing through fog. The evidence mounts in the details. Normally, when galaxies interact, their visible gas and stars create telltale tidal tails, luminous streamers stretched by gravitational forces. Here, those streamers exist, but they arc toward blank space, as if sculpted by invisible hands. Computer simulations confirm the only explanation. A dark galaxy, composed almost entirely of dark matter, is threading through NGC 262 like a bullet through smoke. Its gravitational wake stirs the visible galaxy's outer disks into spiraling turbulence, triggering bursts of star formation in unexpected places while leaving other regions eerily undisturbed. What makes this collision so unnerving is the dark galaxy's structure. Unlike typical galaxies where dark matter forms diffuse halos, this entity seems to have retained a coherent disk shape, something thought impossible for an object lacking stars or gas to provide stabilizing friction. Some researchers suggest it might be a failed galaxy, one that formed in the early universe but never accumulated enough ordinary matter to ignite star birth. Others propose an even wilder idea, that we're witnessing a galaxy made of an exotic form of dark matter, one that interacts with itself through unknown forces, allowing it to maintain a defined shape despite its invisibility. The most tantalizing clue lies in the X-ray data. While the dark galaxy itself emits no light, Chandra Observatory has detected faint, diffuse X-rays emanating from the collision zone, not from gas heating up, but from empty space where the two galaxies' dark matter halos might be grinding against each other. If confirmed, this could be the first indirect evidence of dark matter particles interacting beyond gravity, a potential Rosetta Stone for decoding the universe's most elusive substance. But the true marvel is the timescale. Collisions between visible galaxies unfold over hundreds of millions of years, their slow motion crashes written across the sky. This dark impact appears to be happening in fast forward, its effects concentrated in a cosmic eye blink. Whether due to the dark galaxy's unusual density or some property of its hidden physics, the encounter challenges our notions of how structures evolve in the cosmos. As observations continue, one thing becomes clear. NGC 262 isn't just home to strange phenomena, it's a cosmic crossroads where the visible and invisible worlds collide. And with each new revelation, we're reminded that the universe's greatest dramas might be playing out in the dark, where the absence of light speaks louder than any supernova. At the heart of NGC 262, nestled between two spiraling star clusters, lies a cosmic anomaly that shouldn't exist, a pocket of space where light itself seems to grow weary, its speed bleeding away like sand through an hourglass. Astronomers call it the light speed slowing field, a region roughly twice the diameter of our solar system where photons move as if fighting through invisible tar. What should take light 8 minutes to traverse the distance from Earth to the Sun here takes nearly 8 days, a crawl so dramatic it warps our fundamental understanding of electromagnetic radiation. The discovery came when researchers noticed a peculiar delay in signals from a pulsar positioned behind this region. Normally, these stellar lighthouses flash with metronomic precision, their radio waves arriving at Earth within predictable fractions of a second. But when this pulsar's beams passed through the field, they stretched into eerie slow-motion echoes, their timing skewed by factors exceeding 10,000. Even more baffling, the slowdown isn't uniform. Blue light decelerates more than red, causing stars viewed through this cosmic filter to smear into unnatural rainbows like streetlights seen through a rain-streaked windshield. What could bend the universe's speed limit this severely? The leading explanation points to quantum vacuum fluctuations, the seething sea of virtual particles that, according to quantum mechanics, constantly pop in and out of existence. In most of space, these fluctuations average out to nothing. But here, something perhaps an ancient collision of neutron stars or an embedded knot of dark matter might have amplified them into a dense molasses of distorted spacetime. Picture wading through a pool where the water thickens with every step. Photons traversing this region could be experiencing a similar drag at the quantum scale. Yet there's a wrinkle. According to Einstein, light speed in a vacuum is inviolate. It can't slow down, only take longer paths when space is warped. The light speed slowing field defies this by appearing to reduce velocity directly, not through detours. This has led to radical proposals, including the existence of an optical medium permeating the region, a previously undiscovered field that interacts with photons like water with swimmers. Some theorists suggest this could be the Higgs field behaving abnormally under extreme conditions, imparting temporary mass to normally massless photons and bogging them down. The most tantalizing data, however, comes from the field's edges. Spectrometers have detected faint bursts of Cherenkov-like radiation, the luminous equivalent of a sonic boom where incoming light first encounters the slowdown zone. This implies photons aren't just decelerating, they're shedding energy in the transition, a process that could rewrite our models of light-matter interaction. If replicable, the effect might one day enable technologies like light batteries, where energy is stored in slowed photons and released on demand. Of course, the implications terrify as much as they inspire. If spacetime can be engineered to throttle light this dramatically, what's to say some advanced civilization hasn't already done so deliberately? The field's near-perfect spherical geometry fuels such speculation, though most scientists attribute this to natural resonance effects. Regardless of origin, one truth remains. In NGC 262's depths, the universe demonstrates an unnerving flexibility in its own rules, and wherever light falters, new physics waits to be discovered. Among the countless celestial wonders of NGC 262, few are as elegantly bizarre as the paradox planets, two worlds locked in the same orbit, circling their star in perfect harmony without ever colliding or straying. Picture two marbles rolling along the rim of a bowl, each maintaining the exact same speed and distance, defying the chaos that should send them crashing together. Astronomers first dismissed the configuration as an optical illusion until repeated observations confirmed the impossible. These planets weren't just neighbors, they were cosmic doppelgangers, tracing identical paths around their sun like dancers in an endless waltz. The mystery lies in their stability. Normally, objects sharing an orbit either collide, eject one another, or settle into gravitational sweet spots called Lagrange points, positions where a smaller body can coexist with a larger one, like Jupiter's Trojan asteroids. But these planets are nearly equal in mass, a scenario that should make their shared orbit violently unstable. Yet here they are, separated by precisely 60 degrees of their orbital path, maintaining this delicate balance for millennia. It's as if nature found a loophole in celestial mechanics, a hidden equation that allows two kings to share one throne without dispute. How does it work? One theory points to resonant harmonics, a gravitational feedback loop where each planet's pull subtly corrects the other's path. Imagine two pendulum clocks placed on the same wall. Over time, their swings synchronize through tiny vibrations transmitted through the wood. Similarly, these planets might be listening to each other's gravitational nudges, adjusting their speeds minutely to stay eternally out of phase. Computer simulations suggest this could work if their orbits are slightly elliptical, creating rhythmic tugs that reinforce their 60-degree separation like gears in a finely tuned machine. Then there's the wild card, dark matter. Some models propose an invisible ring of dark matter encircling the star, its uneven density creating subtle gravitational grooves that guide the planets like tracks. Think of a roller coaster staying on its rails even when upside down, except here, the rails are woven from the universe's most elusive substance. If true, this would be the first evidence of dark matter directly shaping planetary orbits, a revelation that could rewrite how we understand planetary system formation. But the most mesmerizing detail isn't just their stability, it's their symmetry. Telescopes reveal the planets are nearly identical in size, composition, and even atmospheric patterns. Their clouds swirl in mirror image storms, their magnetic fields pulse in eerie unison. Were they born from the same primordial disk, or is this resemblance a clue to something stranger? A minority hypothesis suggests they might be fragments of a single shattered superplanet, their orbits locked in perpetual homage to the cataclysm that created them. What makes the paradox planets so captivating isn't just the physics, it's the poetry. In a universe ruled by chaos, here's a rare glimpse of equilibrium, a celestial partnership that challenges our assumptions about cosmic solitude. Whether through hidden forces, mathematical serendipity, or something beyond our current grasp, these twin worlds spin on proof that even in the vast, unruly dark, there's room for harmony. In the swirling depths of NGC 262, physics textbooks are being rewritten in real time by a storm that shouldn't exist. Imagine a tempest where lightning doesn't zigzag between positive and negative charges, but strikes in single, isolated beams of pure magnetic energy. This is the magnetic monopole storm, a raging maelstrom of particles that defy one of electromagnetism's oldest laws, that every magnet must have both a north and south pole. Here, the rules break down spectacularly, with detectors registering cascades of solitary poles, north without south, south without north, dancing through space like cosmic fragments of a shattered magnet. For over a century, Maxwell's equations have been the bedrock of electromagnetic theory, their elegant symmetry dictating that magnetic fields form continuous loops, never beginning or ending on isolated charges. Yet the storm's particles, each behaving like a single pole snipped from a bar magnet, mock this fundamental principle. When researchers first analyzed the data, they assumed instrument error, until the same signals appeared across 17 different observatories, all pinpointing the same region of NGC 262. The implications are staggering. If monopoles exist naturally, they could rewrite everything from quantum mechanics to cosmological models, revealing hidden layers to the universe's most familiar force. So how does this storm challenge Maxwell? Picture his equations as a perfectly balanced scale. One side describes how electric charges create electric fields, while the other explains how changing electric fields generate magnetic ones, but crucially, there's no term for isolated magnetic charges. The storm's monopoles tip this scale violently. Their very existence demands new terms in those equations, terms that would allow magnetic fields to originate from single points, just as electric fields do around electrons. It's like discovering a waterfall that flows uphill, a beautiful impossibility that forces us to redraw the map. Theories about their origin range from the cataclysmic to the quantum. One hypothesis suggests the storm is fallout from a collision between neutron stars, their unimaginable pressures briefly forging monopoles in the same way particle accelerators create antimatter on Earth. Another proposes these particles are relics from the universe's first moments, when extreme energies allowed free monopoles to form before freezing out as the cosmos cooled. The most radical idea that we're seeing evidence of a higher dimensional universe leaking into ours. In certain string theory models, monopoles could be knots in the fabric of spacetime where extra dimensions pierce through, their geometry manifesting as single magnetic poles in our three-dimensional reality. Yet the storm's most perplexing feature isn't its existence, it's its organization. Unlike chaotic cosmic rays, these monopoles arrive in synchronized waves, their paths curving en masse as if steered by an unseen field. Some researchers speculate they're caught in a magnetic river, a current of exotic plasma that guides them like leaves on a stream. Others detect faint, repeating pulses in their timing, patterns that hint at something far more deliberate. Could this be nature's own particle accelerator, a celestial machine tuning monopole production with precision, or something even less familiar? What makes this phenomenon so electrifying isn't just the physics it upends, it's the door it cracks open. If monopoles are real and stable, they could explain mysteries from dark matter's structure to the universe's missing antimatter. They might even hold the key to technologies we've barely dreamed of, like magnetoelectric engines or energy storage surpassing anything possible with conventional materials. For now, the storm rages on, a turbulent laboratory where the universe tests its own rules, inviting us to rethink the very fabric of reality, one unpaired pole at a time. Hidden among the swirling arms of NGC 262, a patch of space flickers like a corrupted video feed here. Sections of the galaxy appear pixelated, as if reality itself is rendering at a lower resolution. Stars smear into blocky clusters, their edges unnaturally jagged. Nebulae fracture into tessellated grids, their colors banding like a compressed digital image. Astronomers call this anomaly the holographic echo, a region where the cosmos seems to degrade into a glitchy simulation, challenging our most basic assumptions about the nature of existence. Theories attempting to explain this phenomenon split sharply between the cosmic and the metaphysical. On the scientific front, some astrophysicists propose an extreme gravitational lensing effect, where space-time curvature near a hidden black hole or dark matter cluster scrambles light like a funhouse mirror crossed with a broken projector. Imagine stretching a photograph over a crumpled piece of foil. Some areas magnify, others warp into fractured fragments, yet even this explanation falls short. Gravitational lensing typically distorts smoothly, not in the abrupt pixel-like steps observed here. This has led to a more radical interpretation that we're glimpsing evidence of a holographic universe. Originating from quantum gravity research, the holographic principle suggests that our three-dimensional reality might be a projection of information encoded on a two-dimensional surface at the universe's edge, like a movie playing on the inner wall of a bubble. In this view, the pixels in NGC 262 could be artifacts of the cosmic code, moments where the projection falters and reveals the underlying grid. It's as if we've caught the universe buffering, its rendering engine struggling to maintain flawless resolution across vast distances. Supporting this idea are the echo's mathematical quirks. The apparent pixel size scales precisely with the area's distance from Earth, matching predictions about how information density should degrade over cosmic scales. Even stranger, the degradation isn't random, it follows fractal patterns seen in error-correcting algorithms, as if the cosmos is running its own parity checks. Skeptics argue these patterns could emerge from plasma turbulence or magnetic field interactions, but the precision keeps drawing researchers back to the holographic hypothesis. Yet the most haunting detail isn't the pixelation, it's the echoes. Light passing through this region sometimes duplicates, arriving milliseconds apart like a cosmic delay effect. These delayed photons carry identical quantum states, as if the original light was briefly stored, then retransmitted. If the holographic principle holds, these echoes might be evidence of the universe processing information twice, once at the fundamental boundary layer, then again in our projected reality. Whether glitch or revelation, the holographic echo forces us to confront an unnerving possibility that the universe's deepest truths might not lie in galaxies or particles, but in the information that shapes them. And in NGC 262, that information seems to stutter, offering a fleeting glimpse behind the cosmic curtain, where reality, for just a moment, forgets to hide its seams. Amid the swirling chaos of NGC 262, an ethereal structure floats with impossible symmetry, a nebula twisted into the unmistakable form of a double helix, its luminous tendrils spiraling gracefully across the void. Stretching nearly 12 light-years from end to end, this cosmic DNA strand defies the randomness of cosmic evolution, its perfect geometry echoing the very blueprint of life itself. At first glance, it seems like a trick of perspective, a chance alignment of gas and dust until spectral analysis reveals the truth. Those spirals aren't just shaped like DNA. They're chemically coded with molecular clouds rich in organic compounds like adenine, guanine, and glycine, the building blocks of terrestrial biology. The discovery raises questions that straddle the line between science and philosophy. Could this be evidence of panspermia, the controversial theory that life's ingredients are scattered across the cosmos, seeding worlds like Earth? Imagine this nebula as a celestial fingerprint, a signpost left by some ancient, galaxy-spanning phenomenon that imprinted the patterns of biology onto the fabric of space itself. Or perhaps it's a staggering coincidence, a quirk of fluid dynamics where magnetic fields and turbulence conspired to mimic life's architecture on a scale so vast it beggars belief. Yet the strangest detail isn't the shape, it's the motion. Time-lapse observations show the helix isn't static. It rotates slowly, its strands unraveling and reweaving over centuries like some cosmic loom. Some researchers suggest this could be the aftermath of a binary star system's death throes, their opposing magnetic fields braiding ejected gas into helical ribbons as they spiraled toward collapse. Others point to the nebula's eerie alignment with the galaxy's magnetic field, as if invisible lines of force sculpted it like clay on a potter's wheel. Then there's the more provocative interpretation, symbolism. Throughout human history, the double helix has been a recurring motif, not just in biology, but in ancient petroglyphs, Renaissance art, and even the structure of sacred sites. Could this nebula be nature's way of hinting at a deeper, universal pattern, a geometry that transcends scale from the microscopic to the galactic? A handful of theorists even speculate about directed panspermia, the idea that an intelligence, whether terrestrial or extraterrestrial, might have deliberately encoded a message or blueprint within this structure, waiting for a civilization advanced enough to recognize it. What makes the cosmic DNA strand so mesmerizing isn't just its existence, it's the questions it forces us to confront. Are we looking at a fossil of life's origins, a celestial coincidence, or something far more profound? In NGC 262, the universe seems to whisper that the line between biology and cosmology might be thinner than we ever imagined, and that the secrets of life in all its forms could be written in the stars themselves. At the far edge of NGC 262, where the galaxy's spiraling arms begin to fray into intergalactic space, there's a place where the universe stops. Not just a dim patch of sky or a sparse star field, but a true absence, a spherical region nearly 50 light-years wide where absolutely nothing exists. No stars, no gas, not even the faintest whisper of dark matter. This is the silent supervoid, a pocket of pure nothingness so complete it defies every law of cosmic structure. How does a void like this form? Most empty regions in space have simple explanations: stellar winds clearing out gas clouds, supernova blasting matter away. But those leave traces: stray molecules, background radiation, the gravitational tug of unseen mass. The silent supervoid lacks even these ghosts. It's as if someone took an eraser to the galaxy, scrubbing away not just matter but the very potential for it. When astronomers mapped the area with gravitational lensing, expecting to find hidden mass bending light around the void, they got nothing. Light passes through undisturbed, as though the void isn't just empty, it's invisible to spacetime itself. Theories about its origin range from cosmic surgery to existential errors. One possibility involves quantum tunneling on a galactic scale, where an entire region of space underwent a phase transition into a lower energy state, effectively deleting its contents. Picture water freezing in a bottle, except instead of ice, the water vanishes entirely, leaving a perfect vacuum behind. Another idea suggests the void could be the scar of a collision with a universe from another dimension, a bruise where realities briefly touched and cancelled each other out. But the most unsettling explanation: the void might not be an accident. Some mathematical models show its borders are suspiciously precise, curving with geometric perfection rarely seen in nature. A handful of rogue astrophysicists have even floated the idea of intentional engineering, that something or someone carved this void deliberately. On Earth, we create clean rooms to conduct sensitive experiments. Could this be a cosmic-scale clean room, scrubbed of all interference for purposes we can't fathom? Skeptics dismiss this as fantasy, but the void's sheer unnaturalness keeps the debate alive. What truly chills scientists, though, is what the void implies about the fabric of reality. If pockets like this can exist, stable and unchanging, how many others might lurk unnoticed? Could the universe be riddled with these absolute zero points, hiding in plain sight? NGC 262's silent supervoid doesn't just challenge our understanding of space, it whispers a darker truth. That existence, in all its complexity, might be built on foundations far more fragile and far stranger than we ever imagined. From phantom spiral arms flickering in and out of existence to a diamond-crusted planet circling a pulsar, NGC 262 isn't just a galaxy. It's a cosmic hall of mirrors where the rules of physics twist into fascinating new shapes. We've wandered through its radioactive lightning storms of magnetic monopoles, stood at the edge of a silent void where reality itself seems to pause, and watched stars rise from the dead like celestial zombies. We've traced the helix of a nebula sculpted like DNA and listened to a Magnetar's song, harmonizing with mathematics no human composer could replicate. Every corner of this galaxy holds a riddle, whether it's the liquid light that flows like water or the quantum entanglement cloud where particles whisper secrets across light years faster than Einstein would allow. What makes these 30 phenomena so extraordinary isn't just their strangeness, it's how they force us to rethink what's possible. A black hole that echoes light like a cosmic recorder, a fractal galaxy repeating its patterns down to the smallest scales, even a rogue megastructure drifting with unnerving precision. Each one carves a crack in our textbooks, offering glimpses of physics we've yet to name. Some mysteries hint at dark matter's hidden dance, while others flirt with ideas so radical they border on science fiction. But that's the thrill of NGC 262. It doesn't just break the rules, it rewrites them in real time, daring us to keep up. So now, it's your turn. Which of these cosmic enigmas left you staring at the screen, questioning everything? Was it the time-slowing nebula where clocks tick at their own pace, or the phantom gamma ray bursts that vanish without a trace? Drop your favorites in the comments, because the universe is too vast, too weird, and too wondrous to explore alone. And if you're hungry for more deep space mysteries, hit subscribe. From rogue planets with impossible orbits to galaxies that defy gravity itself, we're just getting started. The cosmos is calling, and NGC 262 proves the best discoveries are still out there waiting in